Welcome to Ask and Learn.
We have a battery and a recharger that operate at different voltages and currents. For part A of the problem, we're going to need to find the efficiency of the battery as an energy storing device. So first we're going to need to find the energy delivered by the battery. So that energy, which we'll call E1, that's going to be equal to the current that the battery delivers. So that current was 18 milliamps. Times its voltage times the time in seconds. So to convert this to seconds, we multiply it by 60, and then again multiply it by 60. And so the energy that the battery delivers is going to be 248.832 joules. Now we're going to do the same thing for the recharger, and we're going to call this energy E2. So we plug in the current that it delivers, then we plug in the voltage, and then multiply by the time in seconds. And so the energy that the recharger delivers is going to be 469.476 joules. So now to get the efficiency, this is going to be equal to the ratio of E1 to E2 multiplied by 100 to get a percentage. So we plug in E1, then we plug in E2, and then multiply by 100, and we'll get an efficiency of 53%. So next we need to find the internal energy that the battery makes during a charge-discharge cycle. So to get that energy, which we'll just call E, we're going to take the energy that the recharger produces and subtract it with the energy that the battery produces. And so this energy is equal to E2 minus E1 and so we'll get an internal energy stored of 220.644 joules. So now for part C, we're given a value for an effective specific heat. So this value is equal to 975 joules per kilogram times degrees Celsius. And we're asked how much the temperature will increase in the battery if it's surrounded by an ideal thermal insulation and it has this value for the effective specific heat. So we're going to write an equation that this internal energy E is equal to the mass M times the value of C times the change in temperature. So we can plug in E. Plug in the value for the mass. Then we plug in C. And then multiplied by the change in temperature. So then we solve for that change in temperature. And this will give us a value of 15 degrees Celsius.